All right, so get ready, because today we are diving deep into the world of Froops and Glorfingles. And when this request first came in, I thought, oh, this will be a fun one, pretty straightforward pair. But once I actually started looking into it, I realized we are in for a serious deep dive here. These theoretical entities are way more complicated than they first appear.
It's easy to think, well, they always appear together, so they must be pretty similar, right?
Right.
But in the case of Froops and Glorfingles, even though, they coexist in these theoretical ecosystems, it's their differences that really make them tick.
Yeah, it's like saying, well, a hummingbird and a cactus both exist in the desert, so they must be basically the same thing.
Exactly.
So to really kick things off here, one phrase kept popping up over and over again in the research, and that is dynamic modulation. What is that all about?
So dynamic modulation is, it's kind of the essence of a Froop. It's their ability to adapt to almost anything you can throw at them, whether it's a sudden energy shift or a change in their environment, you name it. They're like chameleons on steroids.
They're the ultimate survivors, constantly shifting and changing to keep things running.
Absolutely, yeah. If the universe throws a curveball, a Froop is like, game on. They're constantly adjusting their internal structure, how much energy they're absorbing, even their behavior, all to maintain this perfect balance.
That's incredible. What are the Glorfingles doing during all of this?
So Glorfingles are all about stability. If you imagine the foundation of a skyscraper built to withstand even the strongest earthquake, that's a Glorfingle. They're the anchors, providing that solid base that allows for those more dynamic systems, like our friend the Froop, to exist in the first place.
Okay, so two totally different roles to play here, each with its own unique strengths. But the research also mentioned some pretty significant differences in their actual structure.
Absolutely.
Does that tie into their kind of unique abilities at all?
Yeah, so a Froop structure is all about flexibility and constant change, while a Glorfingle is built for unwavering strength and resilience. They're going to weather any storm.
So to put it another way, a Froop is like a willow tree that bends with the wind, while a Glorfingle is more like a mountain.
Exactly. And this is where it gets even more interesting, because Dr. Barbara McGreeble, who's a leading researcher in the field, has done some fascinating work on this very topic, the structural differences between these two entities. And one key concept she highlights is something called granular heterogeneity, which I know sounds a little intimidating.
It does sound a little intimidating, yeah. Can you break that down for us?
Basically, imagine a Lego structure that's constantly rearranging its own bricks.
Okay.
That's essentially what's happening inside a Froop at a microscopic level. Their internal structure is made up of these tiny components that are constantly shifting, readjusting. It's pretty mind-blowing.
So while a Glorfingle is rocking a solid, unchanging structure, a Froop is more like a constantly moving jigsaw puzzle, always reconfiguring itself.
That's a great way to visualize it. And this actually leads us to one of the most mind-boggling aspects of Froop structure, an inverted negative volumes.
Okay, yeah, that one definitely sounds like something straight out of science fiction.
It does, doesn't it?
Yeah.
Imagine a balloon that can expand infinitely inward without actually changing its size on the outside. That's kind of what a Froop is doing with these inverted negative volumes. They're manipulating the very fabric of space within themselves.
So they're like those fictional bags that are always bigger on the inside than they appear on the outside. What can you actually do with that kind of spatial manipulation, though?
Well, it allows them to do some pretty incredible things. We're talking extreme compaction, squeezing an entire library's worth of information into a sugar cube. Or how about absorbing massive amounts of energy, kind of like a sponge soaking up an ocean? These inverted negative volumes are really the key to a Froop's extreme adaptability.
That's amazing. But it also brings up a big question for me. Why? Why are Froops so dynamic and adaptable, while Glorfingles are content to just, be? What's the purpose behind these drastic differences?
It all comes back to their roles in these theoretical ecosystems. Glorfingles provide stability. They're the anchors. And it's that stability that allows the more dynamic elements, like our friend the Froop, to exist and do their thing.
So it's a perfect partnership. You need that Glorfingle stability to create the conditions for the Froop's adaptability to really shine.
Exactly. They complement each other perfectly, even though they're fundamentally different.
That makes a lot of sense.
Yeah.
But if they're so different, how did anyone ever get them confused in the first place?
Well, I guess it's easy to assume that when two things exist together, they must be similar, right?
Right.
A fascinating historical example of this is Dr. Karlov Frugson and his infamous Froop-Glorfingle duality theory. Have you ever heard of that one?
The name rings a bell. Didn't that theory get completely debunked, though?
Yeah, you're right, it did. Back in 2018, Dr. Frugson published this paper arguing that Froops and Glorfingles were basically two sides of the same coin, just different expressions of the same underlying structure.
Okay, so basically saying that, a fire hydrant and a dachshund are the same because they both exist on city streets.
Exactly.
So where did he go wrong?
Classic mistake. He mistook correlation for causation. Just because he observed them together, he assumed they must be essentially the same. He totally overlooked all these fundamental differences in their structure, their behavior, even their entire purpose within these ecosystems, just because he saw them hanging out together.
That's a good reminder that sometimes we have to look beyond the surface. Sometimes the most fascinating discoveries are hidden in plain sight.
Absolutely. And thankfully, for our understanding of Froops and Glorfingles, researchers like Dr. McGreeble came along and set the record straight. Her work on granular heterogeneity, showing how Froops are constantly changing at a microscopic level, was a major blow to Ferguson's theory.
So she basically took one look at a Froop's constantly shifting internal structure and said, nope, not even close.
Exactly. Glorfingles, they're homogeneous, their structure is the same throughout, but Froops, whole different story.
Which makes you wonder, if they're this different, how do they actually interact within these theoretical ecosystems? Can you give us an example?
Absolutely. Let's imagine an energy surge in what we'll call the bizarro forest, a theoretical ecosystem known for these wild energy fluctuations.
Okay, so like those power surges that fry all your electronics, but on a cosmic scale.
Exactly. Now, when one of these surges hits, the Glorfingles, true to form, they hold steady. They're like the ancient redwoods of this forest, weathering the storm thanks to their inherent stability.
So they're absorbing some of that excess energy, making sure things don't go totally haywire.
Precisely. But when the surge is big enough, that's when the Froops really step up. Remember those inverted negative volumes and their ability to manipulate space and energy?
Yeah.
Well, when that surge hits...
It's dinner time.
Exactly. They use that unique structure to absorb and transform that excess energy, almost like they're slurping down a cosmic milkshake.
So they're not just storing the energy, they're using it and transforming it, almost like they're turning chaos into fuel.
Perfect analogy. They're like living, breathing batteries, recharging themselves from the very chaos that surrounds them. And here's the amazing part. Not only do they benefit from this process, but they also help to regulate the entire ecosystem by preventing those energy surges from spiraling out of control.
Talk about a win-win. But this is getting incredibly complex. How do researchers even begin to study something as mind-boggling as a Froop?
Well, for a long time, it was a real challenge. But then came Dr. Battle and his groundbreaking work on the Yetrich theorem.
Ah, yes, the Yetrich theorem. That was a major turning point in Froop research, wasn't it?
It was a total game changer. For decades, researchers had hit a wall trying to model those inverted negative volumes. But Dr. Battle's solution to the Yetrich theorem, it gave them the tools to unlock this whole new level of understanding.
So we went from completely stumped to aha moments, all thanks to Dr. Battle and his mathematical wizardry.
Exactly. And it led to the development of regressive abstraction theory, a whole new way of looking at these incredibly complex systems.
So is that how we make sense of something as mind-bending as an inverted negative volume? It's like this bridge between science fiction and actual science.
Precisely. It's a way to understand how something could exist, even if it seems completely impossible based on our current understanding of the universe.
So are you saying that Froops, with their inverted negative volumes and granular heterogeneity, could actually exist beyond these theoretical models?
That's the million-dollar question, isn't it? And it's a question that has sparked some, let's say, lively debates within the scientific community.
Well, a good debate is always a sign that we're on something big.
And speaking of debates, I remember reading about a real clash of the titans regarding those very same inverted negative volumes. It involved those negative coefficients.
And yes, the great Gribson-McGreeble debate. Even the most brilliant minds can disagree, especially when you're dealing with something as complex as a Froop.
Exactly. So, for those of us who haven't quite reached regressive abstraction theory mastery, can you give us a quick rundown of the debate? What were they disagreeing about?
Well, in essence, Gribson, who was a strong advocate for regressive abstraction theory, he believed that those negative coefficients associated with a Froop's inverted negative volumes, they would essentially cancel themselves out when you factored in the fourth dimension and negative infinities. So keeping things nice and tidy, mathematically speaking.
Right. Exactly. He called it mathematical elegance. But McGreeble, ever the pragmatist, she relied more on the empirical data, what she observed through experiments and analysis. And her work suggested that those negative coefficients, well, they didn't just disappear. They stuck around, and they were doing something we haven't quite figured out yet.
So it was a battle between theoretical elegance and the often messy reality of scientific observation.
Precisely.
And in the end, who emerged victorious?
Well, that's the beauty of science, isn't it? Sometimes there isn't a clear winner. Both Gribson and McGreeble's work offered valuable insights. It's less about declaring a victor and more about pushing the boundaries of our understanding.
That's a great point. And when those boundaries involve concepts as mind-bending, as inverted negative volumes, well, it's bound to lead to some pretty fascinating discussions. It reminds us that the most exciting discoveries often come from those wait what moments.
Absolutely. And believe me, when it comes to Froops and Glorfingles, there are plenty more of those wait what moments to come.
I have a feeling you're right. But all this talk about theoretical ecosystems and mind-bending physics has me wondering, could Froops and Glorfingles actually exist outside of these models? How would we even begin to find them? And if they are out there, what does that mean for everything?
Those are the questions, aren't they? The questions that keep researchers like me up at night.
And perhaps, just perhaps, they're questions we'll explore further in our next episode of The Deep Dive. But we'll save that for next time. You know, on the one hand, it's exhilarating to think that something as wild as a Froop could actually exist out there. But on the other hand, it's a little unnerving too.
It really makes you question what we think we know about, reality itself.
Right. Just the fact that we can model these things with such detail, thanks to tools like regressive abstraction theory. It's like our understanding of the universe is doing its own version of dynamic modulation, constantly expanding and adapting to accommodate new discoveries and possibilities.
I like that. It's a great analogy. And speaking of pushing those boundaries, we were talking about a rather, shall we say, lively debate about those inverted negative volumes earlier.
Oh yes, the Gribson-McGreeble debate. I'm always fascinated by those moments in science where even the most brilliant minds can't agree.
It happens more often than you might think.
It's a good reminder that even with something as seemingly concrete as, mathematics, there's always more to learn.
Absolutely. And in this case, it was a real clash between theoretical elegance and the often messy data we observe in the real world.
Right. Because Gribson, with his elegant mathematical models, he argued that those negative coefficients in the inverted negative volumes, they would just kind of, cancel themselves out.
That was his idea, yeah. Everything looked nice and neat on paper, mathematically speaking. But McGreeble, she was relying more on her observations of actual Froop behavior, those ever-shifting internal structures, and she just wasn't convinced.
So she was like, hold on, those negative coefficients are sticking around, and they're doing something.
Precisely. Something we haven't quite figured out yet. It's like, what are those things, those magic eye pictures? Where some people can see a 3D image, and other people just see a jumbled mess. Maybe we're still developing the tools or the perspective to fully grasp what those negative coefficients are really up to.
It speaks to the beauty of scientific inquiry, right? It's not always about finding the right answer, but about embracing the unknown, asking those tough questions, even if they lead to more questions than answers.
Exactly. It's about the journey, not just the destination.
Which, speaking of journeys, brings me to something I found particularly fascinating in the research. One of the audio clips I listened to mentioned that Froops are topologically complex, especially when you zoom in on those inverted negative volumes at a granular level.
Ah, yes. Topology.
Can you explain what that means? Because I have to admit, topologically complex sounds a little intimidating.
It's a mouthful for sure, but it's a really cool concept. Imagine like a traditional object, a ball, let's say. It has a fixed volume, right? Set amount of space it occupies.
Right, makes sense.
But a Froop, with those mind-bending inverted negative volumes, it doesn't quite play by those rules. They can essentially fold space within themselves, creating more internal space without actually changing their external dimensions.
Okay, so instead of being limited by the space they occupy, Froops are creating their own space. It's like they've, hacked the system of reality.
That's a great way to think about it. And it's this ability that allows them to, pull off those amazing feats of adaptation we were talking about earlier. Compressing themselves, storing insane amounts of energy, maybe even, and this is where it gets really wild, transforming into entirely new forms. It all stems from their unique topology. It's like they've found a loophole in the laws of physics, or maybe they're operating on a set of laws that we're just beginning to, even glimpse.
It's both amazing and terrifying at the same time.
Right, but it's not just the inverted negative volumes themselves, it's also about how they're arranged within the Froop.
So it's not just that they have these weird pockets of negative space, but those pockets are arranged in a very specific way.
Exactly. Imagine, if you will, those inverted negative volumes, not randomly scattered about, but organized in this incredibly complex, nested hierarchy, almost like a
fractal.
Precisely, like those mesmerizing images where you can zoom in forever and keep seeing the same pattern repeated at smaller and smaller scales.
Yeah, I've seen those. They're trippy.
And it's this fractal-like organization combined with the granular heterogeneity we discussed earlier that allows Froops to maintain this kind of, organized chaos within their structure.
Organized chaos, that's a great way to put it.
Incredibly complex, constantly changing, but still maintaining their overall form and function. It's really quite elegant when you think about it.
Elegant, but also my brain just hit its capacity for strange and wonderful concepts, I think. Can we take a break for one of those cosmic milkshakes the Froops seem to enjoy?
As tempting as that sounds, I do want to highlight one more fascinating aspect of Froop topology that really sets them apart.
Okay, lay it on me.
The concept of negative volume flux.
Negative volume flux. All right, that definitely sounds like something I need a visual aid to fully grasp, but I'm all ears.
So we've talked about how Froops can manipulate space within themselves, right? Well, negative volume flux suggests that this manipulation isn't static. It's a continuous dynamic process. Imagine those inverted negative volumes constantly expanding and contracting, creating these like ripples or waves of spatial distortion that flow throughout the Froop structure.
So it's not just that they have these weird pockets of negative space, it's that those pockets are constantly in motion, influencing everything around them.
Exactly. And this constant flux, this negative volume flux, is thought to be the key to how Froops achieve their incredible adaptive capabilities. They're like little self-contained universes with their own internal weather patterns. But instead of rain and sunshine, it's spatial distortions.
It's like they're conducting a symphony of spatial anomalies within themselves, and we're just beginning to hear the first few notes. This makes those stable Glorfingles seem almost, well, boring in comparison.
Well, boring might not be the right word. It's easy to get caught up in the dynamic, ever-changing nature of Froops. But remember, those steady, reliable Glorfingles, they're what make this whole system work. They're the anchors, the grounding force that prevents everything from descending into utter chaos.
Yeah, you're right. It's like that saying, you can't have rainbows without a little rain.
Exactly.
Glorfingles are the rain that allows those vibrant Froops to exist.
Precisely. It's all about balance. A delicate cosmic dance between stability and change. And it's a reminder that sometimes the most extraordinary things are found not in isolation, but in the interplay between seemingly opposite forces.
Makes you wonder if there are other examples of this kind of duality in our universe, other hidden partnerships that we haven't even begun to imagine.
That's the beauty of science. There's always more to discover, always more questions to ask. And speaking of discoveries, I can't help but mention some of the more, shall we say, radical theories that have emerged from the study of Froops.
Oh, do tell.
Theories about their potential connection to things like, well, dark matter, for example, and even other dimensions.
Okay, now you're just teasing me. Don't leave me hanging.
Don't worry, we wouldn't dream of it. Let's dive into those mind-bending possibilities right after we return from this quick break.
All right, so before the break, you were just starting to tell us about Froops and dark matter and other dimensions. I don't know about you, but I'm ready to have my mind blown.
Well, you know how we've been talking about Dr. Battle's work on the Yeptrick theorem and how it completely revolutionized our understanding of those inverted negative volumes?
Yeah, it's basically the foundation for all this like mind-bending Froop research.
Exactly. So some researchers believe that his work may have actually cracked open the door to understanding even stranger phenomena.
Oh, could like what?
Well, particularly the idea that Froops might actually be interacting with other dimensions.
Wait, are you saying, like, Froops could be interdimensional travelers? They're zipping between universes while the Glorfingles are back here holding down the fort.
It's a pretty wild thought, isn't it? And while it might sound like something straight out of science fiction, there's actually a growing body of theoretical work out there that's exploring this very possibility. That those inverted negative volumes aren't just, manipulating space within our universe, but actually tapping into dimensions that are, right now, beyond our perception.
So it's not just that they're bigger on the inside, it's that the inside might actually be connected to entirely different realities.
Precisely.
Wow. So Froops could be like the key to unlocking the mysteries of the multiverse, like little cosmic explorers surfing the waves between dimensions.
It's a possibility, as exhilarating as it is baffling. And of course it opens up even more questions, like are they even aware of what they're doing? Are they consciously drawn to these other dimensions? Or are they accidentally bumping into, dimensional portals? Could they even be communicating with something on the other side?
Okay, I am officially thoroughly creeped out and utterly fascinated all at the same time. It's amazing to think we started with this, simple question about the differences between Froops and Glorfingles.
Right.
And now here we are contemplating the existence of the multiverse.
It just goes to show sometimes those straightforward questions, those seemingly simple questions, they can lead us down some pretty extraordinary paths of inquiry.
Well, this deep dive has been incredible, full of twists and turns and enough what-if questions to keep us pondering for years. So to wrap things up, what advice would you give to our listeners who, understandably, might be feeling a little overwhelmed right now by the sheer strangeness of Froops and Glorfingles and, the universe they inhabit?
My advice is embrace the mystery of it all. Don't be afraid to ask those big, even seemingly outlandish questions. Because sometimes those what-if moments, those moments where we dare to imagine the impossible, that's where the most profound discoveries are made.
That is great advice. So to all our listeners out there, keep those deep dive requests coming. And in the meantime, keep exploring, keep questioning, and never stop marveling at the wonders of the universe and all the strange and wonderful things that it might contain. Until next time.